Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to Part 5 of Advanced Threat Tactics, Privilege Escalation. In the last lecture, we talked about how to conduct post-exploitation on a compromised system with a beacon payload. In this lecture, we're going to talk about how to elevate your privileges and how to work from that elevated position to harvest credentials and password hashes. We're going to cover user account control and give you some background on what's going on there. We'll go through the privilege escalation options in Beacon. We'll talk about one of my favorite offensive PowerShell scripts, PowerUp. We'll talk about credential and hash harvesting, and we'll talk about the use of Mimikatz in Beacon. So let's start this discussion with user account control. In the old days, the world of Windows XP, it was possible to think of an account as either an administrator account or a non-administrator account, okay? You either had those rights or you didn't. Things changed in the world of Windows Vista. Windows Vista introduced a collection of technologies called user account control. One of the things in this collection of technology is the concept of process integrity level. In Windows, it is possible for a process to run in one of three integrity levels. High, which means administrator rights, medium, which means standard user rights, or low, which is a process with restricted rights. The key thing to know is that a user may be an administrator. They may have the potential to run a process in a high integrity context, but they might be running things with standard user rights, or even worse, low user rights. So to learn a little bit about your user and which groups you're in, one of the things I like to do is whoami/groups in a command shell. This will tell you which groups you're in and which integrity level your process is at. If you see medium mandatory level, that means medium integrity. Low means a low integrity context. And low is primarily for a protected mode browser. And high, of course, means a system administrator rights. Okay, in this post-Vista world, a few things to know about administrator accounts. The SID 500 user, the local administrator, the things this user does will run in a high integrity context, always, okay? Other users who are administrators, by virtue of belonging to an administrator group, the things they do will run as a standard user by default. So most of their processes will run in a medium integrity context, okay? Now, if they want to do something privileged, they have to run a new process in a high integrity context. And that high integrity process will have the full collection of their rights. If you want to assume the rights of an administrator from medium integrity to high integrity, that is a situation you have to elevate out of. Okay, that's a great segue to talk about the privilege escalation options available in Beacon. To go from a local admin in a process in a medium integrity context to a local admin in a high integrity context, use bypass UAC, okay? That's Beacon's command to perform the elevation, and it works in Windows 7, works in Windows 8.1, and so far, as of when this video was cut, it works in 10 as well. Beacon also has an elevate command that uses a memory corruption exploit to elevate you on an unpatched Windows 7 system to system, okay? The elevate command that is in Beacon today is the beginning of what will eventually become Elevate Kit, which will be my pathway to bring memory corruption privilege escalation exploits into Cobalt Strike, okay? So what's there today is just a beginning. Keep an eye on that for more in the future. Get system. Get system is a command to elevate from a local admin in a high integrity context to system. Okay? Run as is a command that lets you specify credentials for a user and kick off a process as them. So you can reuse run as to kick off a process or a beacon as another user. And spawn as uses the same mechanisms as run as, but it's a little bit different. Let's talk about that. Spawn as accepts credentials and a listener, and it uses PowerShell to spawn a beacon session as another user. You can use the spawn as command in the beacon console, or just go right-click, beacon, access, spawn as, pick the credentials you want, pick the listener, and you'll be rocking and rolling. Let's take a look at spawn as. Here we are in Cobalt Strike with a beacon calling back every 5 to 10 seconds. Here's the help for the spawn as command. Okay? Now we can do this command from the console, or we can just go right-click, access, spawn as. Now what we're going to do is use the local administrator account that I happen to know the password for. And since it's a local account, we're going to put a period for the domain piece right here. Now when I elevate, I tend to prefer to use an SMB beacon listener. Okay? And this way my elevated access will chain through the parent beacon. So let's go ahead and hit launch to kick off a beacon as an administrator. And there we go. We now have a beacon running as administrator, okay, chained through our foothold. Cool, very cool. You'll also notice that this account is running in a high integrity context. That's what it means when it's red with lightning bolts in a sessions view. Same thing over here, right? Okay. Now, let's try something a little bit different. Let's try spawn as with a user who is an administrator but is not the SID 500 account. So let's go access, spawn as. Let's do lab, password 1, bang, local account again. And we'll do local beacon HTTP, and you'll see why in a minute. I'm doing that to save time because this command will fail. There we go. This command failed. And you may be asking, why? Why, oh why, Raf, did it fail? Well, error code 267, if you look it up in Microsoft's list of error codes, you will see it has something to do with unable to read the current directory. That's because the lab account will spawn in a medium integrity context. And right now, we are in cuser bdate documents. So if we do this, change over to the C drive, and then do spawn as again, and this time lab, password 1, bang, domain period. And we can do the SMB beacon this time, because I know it'll work. Now, when we do spawn as, we will end up getting a new beacon running as the user lab. Notice though that lab is also in a medium integrity context, even though the user lab is not, or excuse me, is an administrator. We'll talk about how to elevate out of that when we go through bypass UAC. Let's talk about the bypass UAC attack. This is a pretty cool attack, and it's really worth your time to understand how it works. It's a pretty funny story too. The story begins with Windows Vista. Windows Vista was the first version of Windows to introduce the collection of user account control technologies. Okay? And user account control in Windows Vista was also the source of a lot of negative feedback on Microsoft's new operating system. The reason being, users got really tired of being prompted for every privileged thing they tried to do. They got tired of being prompted for file copies. They got tired of being prompted for very routine system use activities. Okay? Microsoft listened to this feedback, and their solution to deal with it was to introduce a mechanism that allows Microsoft programs that are signed with a Microsoft code signing cert and running from a safe folder, like C Windows, to opt out of the UAC prompting. That was the mechanism Microsoft introduced. Now, a gentleman named Leo Davidson didn't like this mechanism. He saw it as pretty anti-competitive. What gives Microsoft the right to make it so that their programs get favorable treatment in terms of ease of use and convenience that other programs are not allowed to have? Okay? So he took great joy in introducing the world to Microsoft's anti-competitive mechanism and the security loophole that came with it. And that's what we're going to go through here. What's funny is this attack really requires two steps, and both steps are made possible by Microsoft's special treatment for itself, okay, but in completely different ways. So let's start the discussion with this. Bypass UAC is a two-step process. First, it takes advantage of a UAC loophole to gain a privileged file copy. The bypass UAC attack uses this privileged file copy to copy an attacker-controlled DLL into a location where it may get loaded into a program that is going to run in a high-integrity context without prompting the user. That's the two steps of this attack. Let's go through them. Here's how the privileged file copy piece works, okay? First, we kick off a program that is running from a safe directory signed with a Microsoft code signing certificate, okay? Notepad.exe is as good of a candidate as any. We then inject our bypass UAC logic into that program. We can do that because both programs are running in a medium integrity context by the same user. So I can inject code into that program. Now that I've got my malicious code running in the process space of this safe, specially treated Microsoft program, I can do some special things. For example, I can load COM objects that receive special treatment when they run from a Microsoft program. So this attack loads the iFile operation COM object. And this iFile operation COM object allows its actions to happen from a high integrity context within a Microsoft signed program running in a medium integrity context, okay? And this COM object gives me the ability to do a privileged file copy. Pretty cool, pretty funny, pretty unexpected. Cool. So I've got the ability to copy my file somewhere. Great. Now, let's talk about the DLL hijacking piece. I use that privileged file copy and copy a malicious DLL to a folder with a vulnerable app. I run the vulnerable app so that it loads my DLL and my malware is executed. Now you may be asking, how does running a program that loads my DLL put me in a high integrity context? Well, again, some Microsoft programs running from a safe folder can choose to opt out of the UAC prompting. So by hijacking one of those programs, I'm basically getting a Microsoft program that will automatically raise itself to a high integrity context to load my DLL. And from there, my code is running in a high integrity context. That is the bypass UAC attack. Okay, we're back where we left off just a demo ago. We have two beacons running in medium integrity context, the BDAID beacon and the lab beacon, okay? Let's go over to the pivot graph so we can see our cool chaining that we're doing. So from the BDAID beacon, let's do whoami/groups. And as soon as this beacon checks in, you will see that BDAID is a local administrator, but we are in a medium integrity context. The command to break out of that is bypass UAC. So let's just go do bypass UAC, local beacon SMB. And there we go. we now have a new beacon running as the user bdade in a high integrity context. Now in the previous demo, we spawned a beacon as the user lab. Let's do a whoami/groups for this user as well. And you can see that this user is also a local administrator, but of course stuck in a medium integrity context. Same type of thing, we can just do access bypass UAC, choose our SMB beacon listener, hit launch, and this payload will give us a new session with the lab user running in a high integrity context. So that is the bypass UAC attack. With privilege escalation, one of my favorite tools is PowerUp. PowerUp is a privilege escalation vulnerability scanner written in PowerShell by Will Schrader. Okay? And what PowerUp does is it looks for different misconfigurations that can help you elevate. To use PowerUp from Beacon, you just do PowerShell import, the local path to PowerUp.ps1, and then you do PowerShell invoke all checks to run the PowerUp vulnerability scanner, if you will. Let's take a look at how to elevate with PowerUp. Here I am in Cobalt Strike with a system beaconing back every 5 seconds. If we do a whoami/groups, you will see that J Smith here is a nobody user on this system. We are not a local administrator. Okay? So what I'm going to do to try to elevate is bring in PowerUp, which is under the Power Tools folder. And we're going to run invoke all checks. Okay? And think of PowerUp as a privilege escalation vulnerability scanner. And I know I said that a moment ago, but can't be said enough. So this script is looking for different things we might be able to use to elevate. Okay? So one of the things that looks most interesting to me is this vulnerable service. It looks like the Adobe ARM service is configured with weak permissions that allows me, as an anybody user, to update that service and make it run whatever I want. And if I can make a service run my executable, well, then I'm system. So what we're going to do is change the configuration of the service to point to an executable of our choice. Let's go to a folder that we know we can write to. So users J Smith. And let's go ahead and export a service executable. And what we're going to export is a stageless SMB beacon. And I did that kind of fast, but if you go attacks, packages, Windows executable S, that's your option to get a stageless SMB beacon. Let's output this as a Windows service executable, press generate, and we'll call it evil-adobe.exe. Now, let's go ahead and upload that file to the target. And let's use the sc command to reconfigure that service. So let's do scconfig, Adobe ARM service, bin path equals, c:users, jsmith, evil-adobe.exe. Let's do sc stop Adobe ARM service in case it's already running, and sc start Adobe ARM service. And at this point, our beacon should be running in memory on the target. Now to assume control of it, we'll just do link 127.0.0.1. And if all went well with our attack, we will establish link to a child beacon that is running a system. We didn't even need to worry about how to egress. So that's how to use PowerUp with Cobalt Strike's beacon. Okay, by this point, presumably we're elevated. Let's talk about how to recover credentials and hashes with Beacon. Okay, Beacon does integrate Mimikatz. If you type logon passwords in the Beacon console, this is like a Mimikatz meta command that will run several credential harvesting techniques. It will pull hashes for domain users, and in Windows 7 environments, it will also pull plain text credentials in some cases as well. You can use hash dump to recover password hashes for local accounts on that system. The hash dump command in Beacon works by injecting into LSASS. Do keep that in mind. There's a mild amount of risk with that. Small, but the risk is still there. Both of these commands will automatically populate Cobalt Strike's credential data model. If you go to View, Credentials, you can see the credentials recovered with these commands. Okay, let's take a look at hash dump and logon passwords. If you go to View, Credentials, this is where credentials brought into the data model will show up. Let's just do access, dump hashes, and there we go. There's the password hashes for the local account. And let's come over here and do access, run Mimikatz. And Mimikatz will work to recover the plain text passwords of any users who interactively logged on since last reboot, or any creds that are in memory. And there's J. Smith's password, plus the password hash of any domain accounts as well. So that's Mimikatz. Same information goes into the cred model as well. Now let's take a moment to focus on Mimikatz for a second. A lot of folks associate Mimikatz as just a way to recover credentials on a Windows system. Mimikatz is really much more than that, okay? Mimikatz is a full-on post-exploitation tool set for advanced persistence. It gives you tools to harvest trust material, meaning credentials, hashes, and Kerberos tickets. And it also gives you tools to repurpose that trust material so you can interact with services with that material you recovered. You can run an arbitrary Mimikatz command in Beacon by just typing Mimikatz, the command you want to run, and its arguments, okay? That will pass the command to Mimikatz's command dispatcher and provide the output back to you. You can also do Mimikatz exclamation point command arguments, and Mimikatz will elevate to system and run the specified command for you as well. With both hashdump and Mimikatz, Beacon is smart enough to recognize if you're on a 32-bit or a 64-bit system and to deploy the right version of Mimikatz or hashdump for you. Here are a few Mimikatz commands I'd like you to be aware of. There's a lot more. This is just meant to be a sample, okay? You can use the LSA dump cache command to dump cache credentials. That's something you would have normally used a Metasploit Framework post module for, but Mimikatz has a command to do it as well. LSA dump SAM is very similar to hash dump. It'll recover user account password hashes. misc : command will re-enable the command shell if it's disabled in the registry. That's pretty cool. misc : memSSP will patch LSASS to automatically log credentials after a user authenticates to that system. And those credentials are stored in C Windows System 32, mimi-lsa.log. It's pretty funny. misc : skeleton is pretty neat. This command patches LSASS to make it so that the Mimikatz password works for all users on the domain. That's pretty wild stuff. Very much an advanced threat tactic. You can also use the process module to suspend a process. Just do process : suspend PID. And that's a way to stop a process from working without actually killing it. And you can do process : resume to resume a process. And that's just a very small sample of what Mimikatz can do. Okay, let's take a look at some of the other things that Mimikatz can do. Let's interact with this beacon that is running as system. Let's do Mimikatz LSA dump cache. This is the command to recover cached credentials of domain users who have logged on to this box. Now you can't use these cached credentials to pass the hash, but you can try to crack them. So the main purpose of these credentials is to allow users to log onto the system even if it can't reach the domain controller. So that's the dumped cached credentials option. Let's take a look at memSSP, which is kind of cool. It's a neat little credential harvesting thing. So let's do Mimikatz memSSP. And Mimikatz will come back and say injected. That's cool. Now let's see if I can do something that causes a user to log in. Running paint as administrator should do the trick. Now let's go find the file with the credentials. This is a 64-bit system. So let's go to sysnative, because that's C Windows System 32. And let's look for mimi.lsa.log. Whoops, not like that though. The clear command will clear the beacon command queue in case you make a mistake. Okay, let's look for mimi.lsa.log. And there it is. Let's just use the type command to put it up on screen. And there we go. There's the credentials for the administrator user who logged on since we patched the memSSP or installed the memory security provider. One thing to note, you are putting this file on the file system, and that's bad tradecraft. I certainly wouldn't recommend this particular tactic in production, but it'd be great for an exercise. Okay, so in this lecture, we talked about privilege escalation and a few privileged actions with Beacon. I introduced you to user account control. I took you through the privilege escalation options in Beacon. We talked about PowerUp. I took you through basic credential and hash harvesting, and we talked about how to use Mimikatz in Beacon. This concludes Part 5 of Advanced Threat Tactics.